All right. Hello, and welcome to the first KubeBuilder controller runtime and controller tools meeting of 2021. Today is Thursday, January 14th. As a reminder, this is being recorded, so don't say anything you don't want recorded for all posterity and uploaded to YouTube. All right. So it looks like we have a pretty full agenda today. So let's get started with Adirio.
Hi. Well, I have a couple points in the agenda, but as it's pretty busy, I will try to be pretty fast so that we can go through all the points. The first one was we are using six Kubernetes-based YAML parsing for the configuration files, and there are a couple special things about this implementation of YAML. It's not parsing YAML directly. It's generating a JSON, the JSON string, and then it's using the JSON string to create again interface, a Go interface, and from that Go interface is then creating the YAML representation. So I was wondering if we really needed this library or we could switch back to the one that we were using previously. There are some advantages and drawbacks from both of the approaches, so I would like to know what the rest of the members think about it. Just to number them, if we use the one from Kubernetes, we are doing this 3 steps process to parse and to marshal and to unmarshal both, and we use JSON tags and marshal JSON methods. If we switch back to the other one, we would have to use marshal YAML instead and YAML tags instead, but we would only have one step to marshal the configuration files. I'm been leaning towards both directions depending on, I've been changing my mind. So I don't know, what do you think about this?
I'll chime in with my 2 cents. I think I don't know if we do this in KubeBuilder right now, but I've seen multiple times in the past where using the non-SIGs k8s.io YAML, if we're ever going to be marshaling or unmarshaling YAML that's destined for the API server, then it seems like we should stick with SIGs k8s.io YAML, because I've seen like unexpected marshaling, unmarshaling things happening if you don't. I don't know if we do that or if we plan on doing that. I kind of have this hunch that we might, based on the fact that we scaffold a bunch of YAML that ends up going to the API server. So unless there's like a pretty good reason not to use that, I think my vote would be to stick with SIGs k8s YAML.
Just to point one thing, I'm referring to the library we are using to store the config files. That's not going to the AP server in any way, but yeah, I get your point.
Would we, I guess the question then is like, would we use different, like would we have both SIGs k8s.io YAML and Go YAML in our Go mod if we were, depending on what we're marshaling?
I don't think so. I would have to check, but I don't think so, because I think that the other parsing would be done in the scaffolded projects, not in KubeBuilder itself. But I would have to check it. I'm not 100% sure.
Yeah, I think you're right. I think if you look at KubeBuilder right now, I think we just, have strings that just get written directly to disk as YAML. But my concern would be if we ever marshal or unmarshal those strings, would we kind of shoot ourselves in the foot by just by default using the one that we're already using and then have these issues where things marshal or unmarshal unexpectedly based on what Kubernetes expects?
Yeah. My main concern to switching back to the other one was that for the next plugins phase, we will probably have to deal with non-Go based plugins, and that will mean uh, passing the configuration file or the configuration information from Go to another language, and we will probably use JSON for that. So that was my main concern.
I mean, the basic issue is that anything other than the 6K thing may inhibit different behavior, which is especially bad if we in any way end up embedding anything that's in an upstream API, because we may end up just not marshalling it correctly or like upstream expected. And if I understood correctly, the only advantage would have been performance, but I think this is only run interactively on developer machines, and I think having two passes of marshalling and unmarshalling internally is just not an issue in that context.
I think from my experience, the main point where you want to use the underlying YAML implementation instead of the SIGs YAML wrapper is if you need the structure preserving part of it. So like in controller tools, there's one point where we use the underlying YAML library in order to do transformations on the YAML without keeping comments and stuff like that, without actually unmarshalling. But that's the main point that I've seen for using that. So if we ever decide to do that, it might be worth revisiting. But if we're not doing that, I don't know if.
Okay.
Yeah, I don't know if it's worth it.
Okay. I will update the issue after the meeting. The second point I wanted to mention was we are doing a pretty, I don't know how to define it. We are handling two flag variables a bit especially when we run a command to try to resolve the plugins that will be used for that command. Those are project version and plugins. And the way that it's resolving the plugins, it may not be the best one. For example, it doesn't allow to set a different set of plugins for a certain command. If we have set KubeBuilder init with some plugins, every command will have to use those plugins. And it doesn't allow to temporarily change it to only for a single command or things like that. And it also doesn't allow to resolve the project version ourselves when it's defined. For example, if I'm using only the version 3 alpha plugin, I know that the config file is going to be a version 3 alpha because it's the only one supported. So I wouldn't need to set that flag. And to solve that, I uploaded an MD, an enhancement proposal. I don't know if you have had time to review it, but I would appreciate some feedback on the new algorithm, on the new approach. I think it will be solve those problems that I mentioned and will be a bit more efficient in that sense.
Right. And that's, I think, a fair thing to question. Originally, we wanted that actually to be the case where you set a plugin on a init and then all other commands would use that plugin. But for example, if you had some plugin that could initialize and create an API for a project, but then you had another plugin that you wanted to use to create a webhook, you couldn't do that using the current scheme. And I think we want to allow that going forward. Just because we provide the option, or we don't require every plugin to implement every single subcommand interface. So by implication, we don't require an init plugin to implement all of the different types of subcommands. So I think that's a fair proposal. And we can probably have discussions about what does this mean semantically in that proposal PR.
Okay. I don't know if there is any other opinion on that topic. We can keep the discussion in that pull request if you want, and we can pass to the next one because there are a lot of points today. Okay, so the last point I had was I was revisiting all the tests and checks that we were doing in KubeBuilder. They are a bit tangled and messed. The first thing is that there are things that are being done in Pro and other things that are being done in GitHub Actions. For example, GitHub Actions allow us to use test for MacBook for Mac, and also allow us to chain tests so that they are not running all until certain conditions have succeeded. So I was wondering if we wanted to migrate everything to GitHub Actions or keep Pro, or maybe migrate everything to Pro. I don't know. I feel like Pro doesn't allow to do everything that GitHub Actions does, and that's a bit of a limiting factor. So I'm a bit leaning to make everything in GitHub Actions and forget about Pro in that sense.
It's one of the reasons for Pro to allow. Oh, I'm sorry.
Go ahead, please.
I was just wondering if one of the reasons for Pro is to allow folks to run the commands individually, rerun a test or something like that, because I don't think you can do that in GitHub. If that's not a need, then we can proceed, but I thought that was one of the uses of it.
If you structure your GitHub Actions separately, there's like a rerun individual action in GitHub Actions. I think part of it might be like, from what I've seen, there's three reasons we're using Prow. The first is that it's what the rest of the Kubernetes project uses by and large. I think I only have two actually, and the second one is that like it gives us for like certain things, it gives us the ability to like, especially for unit tests, it gives us the ability to like gate on who can actually run the tests, because nominally running or technically running the tests, the unit test is running arbitrary code that people upload, and so Prow has the ability to like currently check if someone's in the org or otherwise require OK to test, versus GitHub Actions just runs whatever someone uploads. And so technically someone could upload some sort of malicious code. I think, which is why we currently have a split between GitHub Actions and Prow, versus GitHub Actions, as you mentioned, does allow us to run OSX tests. So technically we're already running those, the technically untrusted code, and has maybe a nicer interface in some places. Anyone else have any points there that I missed?
Yeah, there are two more advantages for Pro. One is V-testing, because if with GitHub Action you have a workflow where at some point in time someone creates a pull request, it gets green tests, then something gets merged to the base branch, say master, that conflicts with this pull request, then nothing will rerun the GitHub Actions, and that pull will merge, that was created sooner but merged later, and you end up with a broken branch. That's one thing. And another one, I know how relevant that is. With Power, you can integrate with test grid, and that in turn is very useful to get some kind of trends for flaky tests and debug them, and yeah, have some longer term view on what tests flag more often, or if tests flag and stuff like that.
Yeah, the first one you mentioned is super important. That one slipped my mind. I think GitHub made progress on fixing that recently, but I don't remember where I saw that. So take that with a grain of salt. But like, yeah, that first one especially is very important. And the test grid is also nice, but like making sure we run the tests against the merged commit that's actually going to be merged is important.
I don't really have a huge opinion one way or the other, but another plus for GitHub Actions is that the code that's used to define the test is stored in the same repository as the code, which dealing with PROW sometimes gets a little bit annoying because you have to make a couple of commits and merges in multiple repositories before you can unblock yourself from something that's failing. I haven't seen that too often with these repos, so maybe that's not a huge deal, but probably a minor plus in the GitHub Actions side of the column.
Yeah, I think the rerun on fail is like, or sorry, not rerun on fail, rerun on merge commit changing before merge is like the blocker. I think we need to leave them in place for that.
Okay. Well, that was my 3 points. So I don't know who's next.
We should maybe add a note to like our dev documentation, just in case people like have this thought in the future, because it will probably occur again. Just as for why things are the way they are.
Okay.
All right, I guess I'm up. So last Friday, I submitted a PR to add some testing clients. In the past, I've brought up the idea of this reactive client. Sully, you had said, you know, reactor to oversimplify, reactor's bad. And so I added these air injector and spy clients that are kind of more special purpose, single purpose clients, testing clients to inject errors or to spy on API calls. And then Alvaro's feedback was, I like reactive client better, or he likes reactive client better. So I thought it would just be good to open a dialogue on what we want to do. Do we want to include reactive client? Do we want to include the other two? Both? Neither? Yep, that's it.
I would not mind a reactive client. I started one on the SDK for myself because I was doing testing and it made testing easier for certain error cases.
Oh, sorry.
No, go
Can I
ahead.
proceed? Okay.
Yeah.
So actually, because David mentioned that you as in Solly are opposed to the reactive client, and I recall there was some discussion very long ago. So my question for Solly would be: are you opposed to the general idea of having a client that allows injecting arbitrary behavior, or just the way client Go implements this?
Yeah. So okay. So I think my number one complaint is that like the actual way client Go implements this is like terrible, right? Like I have like nothing's typed, like everything's type assertions. like the resource name is just like an arbitrary string that sometimes changes out from underneath you depending on how the underlying API machinery is feeling that day. Like it's really not a good experience, especially in the edge cases where it's very opaque. Or at least this is my experience, like writing reactor tests in KK. So if we're going to have a reactor, or if we're going to have something that's like a reactive client, like we should have a controller runtime style interface for it, as opposed to the client Go style interface. And we should make sure that like the weird corner cases are like not weird. So like, you know, things like what happens if you return like false, this is unhandled, and it falls off the end of the handler chain. Like there's really weird behavior in client Go that doesn't really make a ton of sense. There's like parameters that like you think they do one thing and do something else. So like we just need to make sure that like if we're going to have a reactive client, like we need to make sure there is a solid, easy path, and you know, maybe have like easy helpers for like the simple cases, like, you know, inject error or whatever. Separately, like I originally was like very much like I would like to push people towards using mtest instead, but like I think we've gotten enough feedback from everybody at this point that like the reactive client is useful in certain situations, that like I'm no longer hard opposed to a reactive client, but like if we're going to have one, we should have one that, you know, works well and doesn't have all sorts of weird holes in it.
Okay, so the implementation I have actually just uses the client Go implementation of reactors by it's kind of an adapter to to the API. It does like a round trip through converting things to the test actions and then converting those back to controller runtime style calls. Would you, I don't know, I hesitate to like re-implement reactors in our own way, but maybe that sounds like maybe that's what you would prefer. Maybe it wouldn't be so bad. The API to the error injector would actually be, I think, pretty similar to what I would want to create for a reactive client that's, you know, not inspired by client Go or not using client Go's reactors. I don't know how I don't know how much you've looked at it, but maybe that's just some getting some concrete feedback on the design API of reactive client would be useful.
Yeah, I can try to take a look at I haven't gotten a chance to look at the design yet. I'm just kind of skimming over it now. Yeah, the direction of like how inject error works and stuff is definitely, I think like if it's maybe fine if it ends up wrapping the client Go one, but like yeah, we need something like error, like inject error, and B, like, or we need an interface that's more like inject error, and B, like we just need to make sure that like behavior is well documented in terms of like what happens if you do certain things.
I see.
Does
yeah,
that
like
make
you
sense?
mentioned, what happens if you only return false and fall off the end of the chain.
Yeah.
Yeah.
And stuff like that. There are cases where like in the like the, for instance, in the reactive client from client Go, where it will helpfully attempt to apply a label selector for you, but that's not really documented anywhere. So if you don't put the labels on your objects, it would like filter them all out and be like, there's no objects supported, which, you know, maybe is nice, but like we need to make sure it's documented and stuff like that.
Yeah, okay. So it sounds like we're steering in an all of the above resolution to this. Does that, anybody disagree with that? All right, cool. If that's the case, then I'll just like keep going and take everybody's feedback and polish up those clients, because you know they're not done. They're kind of in a please give me feedback state. So all right, thanks. I think that's it. If there's nothing else.
One of the things that we've talked about before, I think, is that using mtest, you end up using the actual Kube API server. So validations you're not writing your own validations in the reactor, and then now you've re-implemented like, you know, the pod API server validation to test your controller to handle like all the different ways it can handle that. Is there something we could do to use the Kube API server validations here as well, so that you don't have to re-implement that in your reactor?
I think that would involve pulling in Kubernetes, and that is not a thing we want to do.
Yeah, I also think that if you're writing tests, sometimes you're probably going to use an object that wouldn't be accepted by the API server, because all the fields the API server requires might be completely irrelevant for whatever you're currently testing. So I'm not even sure if it makes sense in this context.
Yeah, I kind of think if you are using reactive client, like you are hopefully in a situation where like there is a real reason that you just cannot use env-test. Like, and like if you needed that, you would use env-test. And I also kind of think that's how we should document the reactive client. Like, prefer env-test. You know, you can even inject error. Like there, you can wrap the mtest. You can wrap the normal client to inject errors for env-test if you want. But like, if you end up getting into a position where, for some sort of performance reason, or for you know, there's like a really like interesting sequences of events that you need to trigger that are hard to get to trigger in a realistic environment, like here's this and you can use it. But like, you know, we don't recommend just generally using this for these reasons.
I mean, I have other thoughts about that. I mean, but yeah, we don't need, that's fine. We can have that as a community recommendation. It's not, wouldn't be my recommendation, but that's okay.
Yeah, I mean, we can maybe discuss this at the end of the meeting a little bit. This is kind of been the I guess I should probably say this has been my kind of advice since basically as long as we've had mtest. But I'm happy to discuss that at the end of the meeting again, but like, and hear your thoughts, but that could get into a long discussion. So
yeah. All right, thanks.
I think next up is me, but I'm gonna move myself to the bottom because I have a demo. So we can do that last, and we'll get through. I think the other points are probably a little bit quicker. Joe or Jenny, are you ready?
Yeah, ours is real quick. So a couple of weeks ago, we had mentioned that we'd been working on generating an apply client, and that we'd love to get real feedback from the community on that. We're going to have probably in less than a week something that people can do a hands-on experiment with. So basically, the ability to build a KubeBuilder that will also generate applied type bindings in at least one or two ways, either the structs or the builder functions, or both that we mentioned before. The only question we had was, how should we communicate that to this group so that people are interested in trying it out? Could see it. Is there like a mailing list or something that we should use, or Slack, or all of the above?
Yeah, we have there's a mailing list, okay. and you can ping Slack. I think different people probably monitor different ones at different rates.
Okay. Yeah, we'll do a little blast once we have something in place. We'll probably have like a README everybody can follow through. And just for everybody on this line, if you use Apply, we'd really love you to try it out. Basically, what we're going to do is we're going to have like 2 or 3 weeks where it'll be available. You can experiment with it. If you have like an existing CRD that you use KubeBuilder with, it'd be great if you just try running it, see if it does something reasonable for you. We're going to have like a questionnaire at the end that asks like certain preferences that you have about this, and so it could really impact some design decisions. It'll also be used to inform SIG API machinery on which style of generated bindings we like best for Apply. So yeah, I'll send out a blast in hopefully less than a week. Thanks.
All right, the next one is Camilla.
Hello, my one will be fast, I think. I raised this before. We have, just to give you a little bit of context, when we scaffold a project using KubeBuilder, we use the proxy, this image, and it is not rootless. So we have the fix, but we need a upgrade, do a build and push a new image for the Google Cloud. Few people say that you would like to use the upstream for don't need anymore this manual work. Others say that not because it's in Quai, so could you have a downside? And in my opinion, the cons is like how we can ensure the supportability of this image if we don't have that. Anyway, I'm just raising that for we reach a consensus and ask help for build and push this image from someone in the Google that has access and permissions.
Yeah, I think Vince's concern with Quay was that Quay is down a reasonable amount, whereas GCR and Docker Hub are not. So he preferred to not use Quay for that reason. Otherwise, I think it's reasonable to build and push our own, I guess, or just pull and tag and push to GCR. I don't actually think we need to build anything ourselves.
Yeah, the previous iterations of the image have just been, from what I understand, just pull and tag. I'm sorry, but I've been super busy kind of recently, and I haven't had time to work on this, but I think we should have a cloud build config that does the pull and tag instead of requiring an individual, because that's it's not great, right? Like from a like semi-selfish perspective, I don't, if I'm on vacation, I don't want to have to go like push an image. And from like and then like reflecting that to a more project stability perspective, like we shouldn't have it, it's not great that like we have the case of like, oh, we need to go get, a Googler to push this image or whatever. Like that's not a good situation, I think. So I think I mentioned this before, but like I would really like to see us just have like a short cloud build config for that, and then we can just do it like we do for the like bundles that we publish and like the snapshots and stuff like that, where we just have cloud build config sitting on its own branch, and then every time we need to push a new version, we just do a commit to that branch, and we have cloud build looking at that branch, and it just builds a new copy.
I can write something up right after this meeting and make a PR to the tools branch.
Okay, cool. Yeah. It should, I imagine it's probably a pretty short cloud build config, because it should literally just be, pull the existing one, tag it as the new, and then tell cloud build that it needs to be pushed to the new place. Yeah, just let me know when you've done that, and I'll enable cloud build, or I'll make sure that cloud build is enabled.
Thanks.
Just a comment about that. Should we move that part to the other repo, to the Kubernetes KubeBuilder release tools? I don't know if you know what I mean. The branch currently is sitting in Kubernetes 6 KubeBuilder instead of KubeBuilder release tools, and we may want to move it to the release tools repository.
Yeah, we could. Honestly, I'm kind of ambivalent on that. Like it seems like an okay proposal, I guess.
Really, thank you, folks.
All right. If no one has any more comments on that, I think Eric, you have the next one.
Yep. Just a quick announcement. We, I think, are ready to cut V080 controller runtime. This is going along with what we talked about before the holiday, where we are going to try and cut controller runtime versions whenever a new kube version is released, just to keep more closely aligned with upstream. The 070 release was really big, and I think it definitely included one kube bump, but it was I guess a little behind upstream. So going forward, we're going to try and release more frequently to capture new kube versions. So yeah, this next version 080 is not going to be super featureful, except for the kube 120 bump, and that should be happening today.
Cool. All right. And I think we have one more thing before me. Server-side apply. Any plans to include wrapper and controller runtime? Yes. There are plans. Talk to Joe and Jenny, who just appeared briefly. They are working on server-side apply related things. So we'll be probably adopting basically a similar thing, using the same kind of generated structs and stuff generated from controller tools, but just working with our client instead of their client. Does that answer your question?
I guess so. Thank you. I'm sorry. I just had this question a little bit later than other folks, and there are some plans to use server-side apply to do some beta testing in OpenShift next release. So with controller runtime in a short amount of time. I'll definitely talk with Jenny and GBets about this. But yeah, if anything else, I would be eager to try it out, help with anything.
Cool. All right. I don't know if Joe is still here, but Joe, if you are, there's a extra volunteer. All right. Okay, so the last thing is for me. So I have been working on something kind of on and off for a while, and it has I've recently like gotten it to a point where it is demoable. I have been working on an IDL for Kubernetes. So basically the idea is instead of writing Go to define your types, you'd write this IDL. And kind of the benefits are it has like first class concepts for like Kubernetes concepts. So instead of like, writing structs and having to like manually embed metadata and kind, you just write like kind blah, and then that gets generated for you. Hopefully the idea is it also should make it easier for non-Go people to interact, so that we can better generate. We can people don't have to learn Go and install the Go tooling if they're say, writing something in like Python or whatever. And then, maybe make it easier for upstream as well to like generate well-typed and validated things that we can then embed in our CRDs and maybe address, or hopefully address, some of the issues that we've had with the existing Go tooling. So hopefully I'm gonna give a quick demo here, and then also hopefully eventually I love to get everyone's feedback on it, and should be a CAP happening soon for upstream as well. And then I have some not quite finished internals of controller tools that are refactored to like rebase on this as an intermediate step. So hopefully this will be the new internals of controller tools as well. All right, let me share my screen. An application window. I think it's this one. Yeah, it is that one. Cool. All right, cool. Can you all see my screen?
Yep.
Awesome. All right. So basically, let's take a look at. I've actually converted all of Core V1, but it's a little bit intense. So I figured I'd show you kind of a little bit of a snapshot, a subset that shows kind of the important parts. So everything is grouped under a group version. In this, you can have multiple group versions per file. If you want to instead say organize your code by like the kind, so have all the kinds have all of one kind next to each other, or you have maybe a small API and splitting it up between files is unwieldy. And then we have documentation has a special syntax. This prevents weird spacing mistakes and accidentally including comments and other metadata in the documentation, which happens sometimes in Kubernetes. And then the naming is oriented towards like what it ends up looking like in the JSON. This for generating Go, this gets converted into Go forms. As you can see, we have first class concepts of optional and kind of the different types of like lists and mappings that we have in Kubernetes. So lists versus lists maps. Same thing for like defaults. We have, first class concepts of defaults. My Vim syntax highlighting broke. for some reason very briefly. Yeah, you can see we have all the usual suspects. So like wrapper types and structs and volumes, first class concepts of enums, among other things. This should allow us to publish API documentation with like actual descriptions for each of the enum variants, and also to like more easily have validation for enum fields instead of forcing people to write down the Go constants and then write down / plus enum separately. And then finally, we also have unions, which is, I know, been a feature that a lot of people are asking for. So this is like, the kind of Kubernetes standard one-ofs. So in this case, we have a union with 2 variants, host path and empty-dir. This is just an example of volume source. Obviously, in the real volume source, there's more, but I got a little lazy and didn't want to type out the whole thing. And then finally, we have kind of markers, a more structured form of markers as an extension point. So there's some built-in ones for like common metadata, and then you'll be able to define your own and use them like this. Markers are strongly typed, and you have to import the definitions of the things that you want to use. So no more like, oh, I accidentally misspelled this marker in controller tools. Just like ignored it because it didn't know if I actually meant a different one, because you have to import them and specifically type them. The new parser will be able to go, oh, I don't know what this is. You didn't import the definition, so I'm going to error out, which is hopefully a better user experience. Any questions so far? I'm assuming I moved a little fast there just because we're running a little short in time. Right, I'll take that as a no comment questions for now. So the architecture of the parser, and this will eventually be bundled into a single helpful command, was kind of like modeled after the way Proto does things. So we have a kind of, whoops, that is the wrong directory. Hold on, I CD'd up too many directories. There you go. All right, so we have an intermediate form that is like serialized to disk that can be consumed immediately, or like we can save around. This is intended for consumption by tooling, so like various parts of controller tools. Theoretically, you could also like, you could cache this or keep it on disk around so that you don't have to like recompile every time, or distribute it or whatever. So like if we say, for example, wanted to try compiling our example, and let's hope that I didn't anger the demo gods and accidentally change something late last night. And this is just going to spit out the like text form of the intermediate that it's representing, the intermediate data that it's generating. KDL. All right, so we've generated some intermediate parse form. This has actually been serialized to all around.ckdl, which we can see is a lovely blob of compiled data. It's in proto form, so like any tooling can import the proto definitions and make use of it. And then we can feed that into this is just like a hacked up form of the same machinery that we've used from controller tools. And I have evidently screwed something up. I have angered the demo gods. Let's see this. We can quickly see if I can figure out what I screwed up, but otherwise.
It's not a demo unless you screw something up.
It's definitely not a demo unless I screw something up. What did I screw up? Weird. It's not liking my, oh, that's why. You know, it would help if I like actually specified the right syntax. There we go. So you can see we've got like an actual CRD that we've generated here, as one might have expected, with like API version, kind, metadata, the spec that we described, all of our documentation. There's we have, we even for like that union we had, we generated like the very weird, complicated blob of open API that's required to get a tagged union to work in Kubernetes structural schema without it complaining. Yeah, so that is what I have so far. I also have not quite ported from my initial prototype the equivalent of like a Go format for this, and also a tool to help you migrate over from Go definitions. You give it Go definitions, it spits out the intermediate representation, and then there's a separate tool that I haven't quite finished porting from my initial Rust prototype that spits back out from intermediate representation the equivalent textual IDL form. Does anyone have any questions, comments, concerns?
I got one. So what's your vision for like this long term? Would we, instead of scaffolding like Go files for the types, would we scaffold this instead and then generate Go and CRDs?
Yeah, that would be the idea. The plan for upstream as well is hopefully there's, so I plan on having it kept for this within the next couple weeks, and showing it off to API machinery, and then hopefully the idea is upstream adopts this as well and generates the Go types as well. But yeah, the idea is we'd scaffold this out, and you'd be able to write this instead. And awesome. we'd maintain compatibility in controller tools. So we'd probably maintain the ability to pull in Go, at least for a while. But like the internal tooling would all be around the intermediate, like the compiled form. So like we just compile the Go to like the compiled form internally. Yeah, so theoretically, you could go from CKDL to Java. So Kubernetes, the project, is definitely going to maintain a generator for Go. I know I've talked to some folks upstream, and there's like concerns over whether or not we want to generate other things off of like the eventual Open API or versus the CKDL. I like generating off of the CKDL because you kind of get a more constrained problem set, and so like you can generate like better, you can make better decisions about what you generate, especially in more strongly typed languages. So like you can generate like Rust enums for unions, for instance, or stuff like that. But yeah, you could definitely like, one of the things I wanted to enable is people consuming this and doing interesting things with it. Generating better API documentation, for instance, is like a thing that we could do as well. Yeah, I have my initial stuff. I'll drop a link in the document, but I have the initial work if anyone wants to like go and play around with the syntax. There's the 2 compilers that you saw below or here, a couple of examples, a kind of formal-ish grammar, and some Vim syntax highlighting if you're working in Vim. So yeah, try it out. File, definitely, like, you can file issues on this repository if you like encounter anything that you think is breaking or doesn't work for you or whatever. Yeah, cool. Let me know.
We considered how you would potentially ship the KCDL with a given controller.
What do you mean? Like how?
Yeah, sorry, that's probably like a really weird question coming out of nowhere. I guess what I was considering is controller A is written in Rust, controller B is written in Go. Controller A wants to use controller B, but it would have to then generate types for itself, right? And how we could, if controller B is installed in a cluster, how could they generate those types? Before I would assume that would be from the Open API spec that is served by Discovery. So I guess I was asking if we're potentially also thinking about serving in some way the KCDL for this, so you can easily generate your type based on that.
I don't think we have any immediate plans for doing something like that.
Okay.
It's definitely not in the MVP. Yeah, this is like, there are upsides and downsides about generating everything based on the CKDL. This is one of them. On the other hand, generating based on the Open API from the CRD is a little bit wonky because you don't have any type names in it.
Yep.
And you lose a whole lot of structured information. So like that's like maybe a longer term discussion.
Okay.
My thoughts kind of short term would be just like, today, we effectively say distribute the Go types, and instead we'd say distribute the KDL or the CKDL. And then like the parser can import either via from KDL or CKDL directly. And so you could generate your Rust bindings that way. It's a little bit closer to our traditional method, but like it's also doesn't require any changes to the API server or whatever.
Right. Yeah, just wondering if it's been brought up or if the question had been asked, I guess. So thanks.
All right. I think unless anybody has any other quick questions or comments, I think we are over time for today. So with that, I'll see y'all in a couple weeks.
Great demo. Thanks a lot, everybody.
Goodbye.